All right, today we're talking about solving linear equations and inequalities, section 2.1. Moving along here in chapter 2. All right, vocab here. An equation, mathematical statement that two expressions are equivalent. Okay, essentially an equation has what would be an equal sign here. We're going to be dealing with the equations in the top there. For example, x plus 4 equals 7. Looking at equations very similar to those. Ours will obviously be a lot tougher, being in Algebra 2. But looking at solving equations today. Solution set of an equation is a set of values that make an equation true. In that box there, it's supposed to say x squared equals 9. I don't know why the box came on it. But solution set is anything that makes that statement true. For example, their solution set is negative 3 and 3. Okay, because negative 3 squared is positive 9. 3 squared is a positive 9. That's the solution set. Most things we're doing today, we'll be getting one solution for everything. We will talk about all solutions as well as no solution answers as well. So that's kind of where the advanced part comes in here. Linear equation in one variable is an equation that can be written in the form ax equals b. For example, like this one, if you subtract the 1 over there, you get x equals 6, which would be that form ax equals b. A and b in constants are a does not equal 0. Okay. Identity. Identity is an equation that's true for all values of the variables. Essentially, identity really just means all solutions. Okay. You get the identity or you get all solutions when your final statement is a true statement. For example, if I get 3 equals 3, well, that is a true statement. Anytime I plug anything in for x, it's always going to come out to be the same on either side. Okay. The opposite of that would be what's called a contradiction, and that is an equation that has no solution. Okay, so typically we always say either all solutions or no solutions for our answers. Okay, you don't have to say identity or contradiction. You'll say either all solutions or no solutions. Sometimes for no solution, they will use the symbol for no solution, something like that. Sometimes for all solutions, they will say all real numbers or use the all or the real number sign, which looks something like that. It's popping up here in a sec. There it is. So again, those are kind of the symbols you could use, but if you use all solutions and no solutions, that is just fine. That's what it works. But you get no solution when your final statement is a false statement. For example, 1 equals 0 is a false statement. And then next we have an inequality. We'll talk about inequalities at the end. An inequality is a statement that compares two expressions by using one of the following signs: the less than, the greater than, less than or equal to, greater than or equal to, or the not equal to sign. Really, inequalities are just like equations. There is just one difference. Does anybody know when you solve an inequality what the one difference is? There's one thing you have to remember when solving an inequality, and deals when you get your answer. When you multiply or divide by a negative, what do you have to do? Flip the sign. Yeah, that's the one difference between equations and inequalities, is I do have to remember to flip that sign when I am multiplying or dividing by negative. Nice job. All right, so let's look at a couple problems here. All right, so we're going to talk about simplifying before solving equations. Now, a lot of times, I talk about certain sides of the equation. So, for example, I have like a left and a right side. If I look here, I draw a line down the equal sign. I can visibly see there's my left side over here, there's my right side over here. Okay, I can visibly see that. When I have variables and numbers on the same side, for example, I have 6x and I have a negative 8x. They're on the same side. I can combine them right away. I don't have to move anything. I can combine them. What does 6x minus 8x get me, John? So I get negative 2x plus 3. Comes straight down, equals 13. Again, everything else comes straight down. I just kind of combine what I can, then I bring everything else down and keep working through. From here, it's just a two-step equation. Two-step meaning I have two steps till I get my answer. What's my next step going to be, Andy? Subtract 3. Giving us negative 2x equals 10. And then I do what, Andy? Divide by negative 2. And I get an answer of x equals negative 5. Okay? So again, notice when I have variables on the same side, I can combine. We will talk about problems later that have them on different sides, so I have to do something else. Number 2, again, draw my line down. I can visibly see my x's are on the same side. Okay, 8x minus 5x gets me what, Sage? What did you say? 3x. Nice job. So I get 3x minus 21 equals a negative 15. Now, do always remember when you are combining them, make sure you always take the variable or the sign that's in front. For example, that was like a negative 5 because that's subtracting 5. From here, two-step equation. What's my next step, Colin?
Divide. No, just kidding. Add 21.
Thank you.
I already did this.
You're ahead of me. 3x equals 6. Negative 15 plus 21 is 6, right? Now what do I want to do, Colin? Divide by 3. And I get an answer of what, Colin?
2.
X equals 2. Very good. And then last step, what can I always do if I wanted to check my answer?
Plug it in.
I can take this answer and plug it right back in for x there and check to see if my left side equals my right side. All right, next problem's here. Same idea. I need to do some simplifying before I solve. Now, anytime I see this setup right here, what's my thought process, Reagan? Distribute. On a problem like this, though, what am I technically distributing, John? Negative. Yeah, and there's always that invisible 1 there. Okay, yeah, really I'm just associating the negative throughout it. But really, yeah, there's that invisible 1 there. So I'm taking the negative 1 to everything, getting me 9 equals 6 minus x minus 2. Okay. Can I combine the 6 and the 2? They're on the same side. Yes. So I get 9 equals 4 minus x. So I took my 6 and my negative 2 and combined them. So we get 9 equals 4 minus x. What's my next step going to be here, Bailey? So I want to do the opposite. So I subtract the 4. Good work. Giving me 5 equals negative x. Is that my answer now? No, x is not alone. What's in front of that x? It's a negative 1. So I divide everything by that negative 1, giving me my answer now, x equals negative 5. Do remember that. Okay, we don't want to get a negative in front. We want to solve for it's just the single variable. Number 4, same idea. What do I want to do right there, Sophie? I want to distribute 4x minus 8 plus 2x equals 40. Are my variables on the same side, Sophie? So I'm going to combine them. What's 4x plus 2x? Good. I get 6x minus 8 equals 40. Now what do I want to do, Bailey? Add the 8. Get 6x equals 48. Now I do what, Sage?
Divide by 6x.
And I get x equals what, Sage? 48 divided by 6? Eight. Oh, nice job. All right, so now I have some that have variables on both sides. So if I draw my line here, I have variables on either side of my line. Now again, personal preference for a lot of students here. It doesn't really matter which way you go. You can always get the same answer. I always like to keep the variable positive. I move everything to keep it positive that way. I don't have to deal with negatives at the end, which are a lot of times where mistakes come. And then when I get to inequalities, I don't have to worry about having to flip that sign again. Okay, I just keep my variables always positive and just kind of makes everything a little bit easier. So, for example, on this one, I would want to subtract my 4k because I need to move it to the other side. So now I need to move it by doing the opposite. So I'm going to subtract 4k to both sides. Okay, so 7k minus 4k is 3k. Equals 15. 3k equals 15. Now I do what, Jack?
Divide 3.
And I get an answer of k equals 5. Now again, when we get to problems, more advanced problems later, it doesn't really matter which way you go, but again, if you make it always positive, it's just getting less mistakes that you could make later on. So for example, number 6 here. I can move the 5x to the right, or I can move the 3x to the left. Doesn't matter. Which one do you want to do, Andy? So I'm going to subtract 3x, right? So I subtract 3x on both sides. 5x minus 3x is? So 2x minus 2 equals 4. What's my next step, Andy? Add 2. Giving me 2x equals 6. Get an answer of what, Andy? X equals 3. Good work. All right, try these two on your own. All right, Bailey, what do you have for answer number 7? Y equals 12, nice job. What was the first thing you had to do on number 7? Distribute. Yep, anytime you have that number in front, make sure you distribute. Then you solve. Oops. And you get y equals 12, nice job. Number 8, again, what's one of the first things you probably had to do there, Reagan? Distribute. And when you did, you got an answer of what then, Reagan?
1.
K equals 1, nice job. All right, so moving along here, solving equations for one variable, pretty simple. It's when we get these infinitely many or all solutions and no solution answers that we struggle. Okay, so infinitely many is really just a thing for all solutions. Okay, then we have no solutions. So as I look at number 9 here, if I draw my line, I have my left and right sides. I need to move my variable first. Now again, preference, you could move numbers first, that's fine. I'm always a person that wants to move variables first. So what would I have to do to my variable, John? If I'm subtracting 5x and I move it, doing the opposite, so I'm going to add 5x, right? Okay, so I add 5x to both sides. Now here's where students make their mistakes. What's a negative 5x plus 5x? 0. It cancels, getting me nothing. A lot of times students, when they get that, they want to be left with just an x. No, that implies there's a 1x. We get 0x, nothing, cancels out, leaving me with 4 equals 6 minus 2. Well, 6 minus 2 is just what, Sophie? 4. So I get 4 equals 4. Now I check. I have no variable, so I'm going to check here. Is that a true solution? Is that a true statement? 4 equals 4. It's a true statement, so my answer here is going to be all solutions. Okay, when my variables cancel out and I'm left with nothing else but constants, I check. Is it a true statement or is it a false statement? If it's a true statement, I'm going to get all solutions. If it's a false statement, I'm going to get no solutions. Okay, so let's look at number 10 here. Same idea. I have variables on the same side. Can I combine negative 8x and a positive 9x? Yes. What's negative 8x plus 9x get me, Jack?
1x.
So I get x plus 6 equals negative 17 plus x. Need to move my variables to the same side. Try to here. What am I going to have to do, John? I minus the x. X minus x really gets me 0. They cancel out, giving me 6 equals negative 17. I'm left with just numbers. Is that a true statement? Does 6 equal negative 17? No, never. So that's going to be a no solution. No solution. All right, try these two on your own here. All right, Reagan, what do you think about number 11? Yeah. Yeah, the answer there is no solution. Nice job. No matter which way you work it, you can get an answer of like 7 equals 10. And that does not work out. What about number 12? What do you say, Colin? All solutions. You take a 50-50 shot since the other one was no? Or
No, I did it. I worked it out.
good work. Yeah, all solution. Good work. So again, take note. When the variables cancel out, which they can happen, that's usually when we're going to get are either all solutions or no solution answers. All right, last thing we're going to talk about here today, we are going to talk about the inequalities. As I said earlier, inequalities, just like equations, the only difference is when I multiply or divide both sides by a negative, I need to remember to flip that sign. So for example, if I look at number 13, just a two-step equation there, what would I do first, Justin? Subtract the 7. Giving me 6a is greater than 12. And then I do what, Justin? Divide by 6, and I get an answer of what? A is greater than 2. Nice job. Okay, so that one's pretty straightforward. It's this next one we have to remember some details on. John, what would I need to do first here? Add 4. giving me negative 3x is less than or equal to 18. Now what am I going to do, John? Divide by that negative 3. And what's the key detail I have to remember? Yeah, I need to flip that inequality symbol around because I'm dividing by a negative. Whenever I multiply or divide both sides by a negative, I need to flip that inequality symbol around, and I get my answer, x is greater than or equal to negative 6. So again, take note, flip that thing around. Try these two. Bailey, what do you have for answer number 15? X is greater than 2? Good job. Now let's talk about that. What does actually mean is the answer? If x is greater than 2, give me an actual solution for this answer, Andy. 3. Yeah. Anything that's bigger than 2. Can 2 be a solution here? No, because it has to be just greater than. Unless a lot of times students forget about that. We are talking about inequalities here, so it has to be greater than 2. So any number greater than 2 is a solution here. What about number 16? What's the answer to 16, John? Very good. X is greater than or equal to negative what? Thank you. And give me a possible solution there, Jack. So anything. Give me one.
Negative 4.
Negative 4 could be a solution here. Why can negative 4 be a solution here? Yeah, because there's that equal to part right there. It's greater than or equal to. So now negative 4 is included. And then again, anything greater than that could be negative 3 as well. Nice job. Here is your assignment.